So today we're going to look at lines and graphing them in the slope-intercept form. So remember in Chapter 2, you learned slope-intercept form from a linear equation, and that is in the form of y equals mx plus b, where m is the slope and b is the y-intercept. So let's take a look at our steps here for graphing a line from the slope-intercept form. So step 1 is identify the y-intercept, or the b value. This is the value on the y-axis where you will begin your graph. So aka, in simple terms, every straight line in the coordinate plane will at some point cross the y-axis. So we have to make sure we get the y-intercept. And then step 2 is to plot that y-intercept. Step 3, identify the slope of the line, the m value, and this is when we talk about rise over run. Step 4, use the slope to rise and run from the y-intercept and move to the next point on the line. And then the last step would to be connect the points. So let's take a look at this example here. So remember, y equals mx plus b is the slope-intercept form. So the y-intercept of this equation is positive 4 or 0, 4. So let's go ahead and label that on our graph. That would be here, 1, 2, 3, and 4. So there is our y-intercept. The slope of this would be 2 over 3. So that means we move blank 2 units and blank 3 units from the y-intercept. So rise over run. So up 2 units, right 3 units. So then we go ahead and plot the points from the y-intercept. So rise over run. Up 2 over 3. Up 2 over 3. Oops, made a little error here. Let's erase this. So it would first be up 2 over 3. Up 2 over 3. And now if we want to go ahead and continue off to the left, we would do the opposite. Down 2 over 3. Down 2 over 3. And if we now go ahead and connect all of our points, this is that line. And we have to make sure we put arrows on the end because this is a continuous line. Down here it says, what if the slope was negative 2/3? Would anything change when graphing the line? Yes, negative 2/3 would give us a negative slope. So instead of going up 2 and to the right 3, we would go down 2 to the right 3. Down 2 to the right 3. And this would be an opposite slope. So positive slopes go up and down. Negative slopes go left to right and go up to down. So let's look at these examples here and graph them. So for A, my y-intercept is negative 3. The slope is 1/2. So you would go up 1 to the right 2. Up 1 to the right 2. And if you continued, your line would look as such. Letter B, the y-intercept is positive 1. Now, the slope is negative 2 or negative 2 over 1. So that means we are going down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. And then if we wanted to graph in the other direction, we would do the opposite. Go up 2 to the left 1. And there is that line graphed. Now, here we are determining an appropriate scale when it comes to graphing linear equations. So let's take a look at the equation in exercise number 3 and determine the most appropriate scale to graph the line. So y equals 50x plus 25. Obviously, 50x plus 25, they're bigger numbers. Plus 25 would be pretty high if we counted by 1. So the scale, I would recommend counting by 5s. So 5, 10, 15, 20. And doing that for all of our axes here. So go up by 5s in the positive and negative directions. And did you scale both axes or just one? You could scale both by 5. The thing is you're going to want to do that for this. So if our y-intercept is 0.25, and take a look, our slope would make us want to do that. So we have to go up 50 to the right 1. So if we went up 50, we would end up at this point here, and then to the right 1. So it would look something like this, and then we would also go down 50 to the right 1. So here is what that line would look like. Okay, so let's apply this to some real-life word problems. So Josh walks 5 blocks from his house to his friends and then back to his house. So here's my starting point. So 0, 1, 2, 3, 4, and 5. This represents our blocks walked. On the x-axis, we have our amount of time. So this is 1 minute, 2, 3, 4, and 5. It says here that Josh was going home and walked at a rate of 1 block per minute. So that means every minute he's going down a block and getting closer to his house. How can we write an equation for that? So his rate of change is 1 block per minute. So that would be our slope. And our y-intercept is 5. So this, again, we were going down 1 to the right 1. So that would be negative x plus 5. So we graphed our equation here. And now what units are represented on the y-axis? We just said that was the amount of blocks he was at. On the x-axis, we had the amount of minutes he was at. And then it says what units are represented by the slope, and this is the rate of change of blocks per minute. So blocks walked per minute. Let's take a look now at the next one down here. So exercise 5 says Valerie is saving money for a new bicycle. She already saved $150. So we start at 150 on the the y-axis here as our scale. And then this is her weeks as they pass by. So each week she saves $50. So that means every week we're adding $50 to her savings. She started at 150. So that would be our y-intercept. And now it looks like we're going up at a rate of $50 per week. So that would be up 50 and over 1. So that's 50x. And now here it says, how can we find out how much she saves after 3 weeks? Well, we would plug in now for our x 3, add to 150, and she would be at $300 of savings. So if we look at our graph, after 3 weeks, if we match it up, we end up at 300 on the y-axis. If the bicycle costs $450, how many weeks will it take Valerie before she is able to buy this bicycle? Well, $450, we'd have to go up 1 more week up the graph a little bit more. If she's saving $50 per week, then that means right about around week 7. Or actually, I'd say week 6 here. So look, so 50 times 6 equals our 300 plus 150. That would give us $450.